Good afternoon. Can you hear me?
Yes, sir. Good afternoon.
Okay. So we can start our lecture today. So far, in the last class, we have covered energy rates or tariff related theory, right? So there are, I think we have covered 4 or 5 types of tariff, starting from a fixed type of rate design, then step meter rate, modified step meter rate, right? And then we have covered 3-part tariff, and we have covered on math from straight meter rate, right? So from that energy tariff, one particular assignment has been given. If you see in your assignment question, there is one question to design or to calculate the overall bill for a particular uh, month, okay, or particular year, whatever. So this type of math will be in the exam. Follow the assignment questions. Uh, you will be given at least 3 sets of question in a final exam. There will be no options. You have to solve each of the questions in the final exam. Okay. So today we will cover another tariff-related math, which is directly not related to the bill design, that is related to the economical distribution or fuel cost related math. After that math, we will cover our last lecture that is related to the heat rate. Okay, so we can start our math now. What is the lecture number of today's lecture? Lecture 13.
13.
Okay. I hope everyone can see my screen. So the question is, I'm writing the question so that you can understand the question easily. So there are 2 generators. So each of the generator utilizes fuel. So fuel costs for these 2 generators, A and B, for any power plant are given by some equation. Okay. It is given by a fuel rate equation. Okay. So first one for first power generating unit, first power plant or first generator, DFA by DPA, which is 0.06 PA plus 11.4. So this equation has constant, right? If you know the energy rate, there are some straight line, okay? Mx plus C, you see in the last lecture, that fuel rate, any type of rate can be designed by this equation. If there is some C, you can draw it in the top, right? So this type of graph we have already covered in three-part tariff design. So this is some type of graph, but that bill or that rate is basically based on the overall plant capacity and the fuel rate, fuel cost, the fuel you need to purchase. Okay, it is basically based on gas-based power plant or for diesel-based power plant. This equation particularly is fuel-based power plants. Okay, is for fuel-based power plants. So where you can see P is in megawatt. This is megawatt. That is the capacity of that power plant. And F is the fuel rate. F means fuel rate. Okay, and we can say this is some BDT per hour. Okay, so to produce energy, you need to run particular generator for particular time, and for that period of time, if you require an amount of fuel, that price of the fuel per hour is called fuel rate. Okay, so from that, another generating plant B, which has maybe the fuel rate of dFB by dPB. The equation is like that, something PB plus 10. That is our constant. According to our rate design, we have some constant cost, okay, maintenance cost. So all this cost summing up together to provide you the cost of that generating plant. So the question is asked to find the economical loading of that 2 units. Okay, that is the question. And another part is these 2 generators actually supplied to a particular load, which is 150 megawatt. So when it is supplying to the 150 megawatt power, okay, that is our load demand. Total load demand is 150 megawatt. So generator 1 and generator 2, A and B, it provides to the 150 megawatt load, or supplies power to the 150 megawatt load. So another finding, you need to find the loss in fuel cost per hour. Okay, fuel cost per hour if the 2 generators sharing equal load. Okay, so if load is equally shared to these generators. So you have 2 generators set and they shared the whole load. That means if it is 150 megawatt, you need to divide it, okay? Like 75 megawatt and 75 megawatt, 75 megawatt each. So what about the fuel cost per hour in that scenario? And what about the losses if you consider equal load sharing or uneven load sharing, unequal load sharing? What about the fuel cost difference? Okay, or we can say, what about the depreciation from sharing equal load of the by the 2 generators or not equal share by the 2 generators? What about the difference between that fuel costs? Okay, so that we need to calculate. That is the main question. The question can be may have different scenarios or case you need to practice, like the A and B is sharing 150 megawatt load. We may provide you some scenarios like minimum A can minimum share some values. Suppose 30 megawatt. A cannot share below than that. B cannot share more than that, maybe 70 megawatt. So in that scenario, you need to design what about the value for A, what about the value for B, find it out. The question A can be designed like that. So just practice it, very simple math. So we can start the solution. First of all, we need to find it out what about the value of PA and PB for question number A, where you are sharing your load to the 150 megawatt and you don't know the value for power generator unit and A and power generator unit B. So you have two equations here, the fuel rate for generator A, fuel rate for generator B. For economical purpose, we may consider that this is the optimal design. These two equations should provide you the equal fuel rate. We can consider it for economical loading. That is called economic loading. Okay. So considering that the first generator and second generator will share 150 megawatt load, and the fuel rate for DFA by DPA should equal to the DFB by DPB for economical loading. Okay, that is our economical loading. You can get less fuel rate in this scenario. Maybe in this case, PA and PB is not equal. So to find it out, you need to put the equations here. That is the first equation. And this is our second equation. So solving 1 and 2, you can get the PA and PB. So can you please solve these two equations? A very simple equation. So please solve it and find the value of PA and PB. Can you please solve it? I will provide you some 2 or 3 minutes to solve the equation. Okay, put the PA into these equations. Suppose PA equal to 150 minus PB. So from 1, put the equations here, then calculate to get the PB. Okay. If you get the PB, you can again get the PA. So what about the value for PA and PB? Anyone doing this solution?
Sir, PA is 1.53 and PB is...
No. It should not be like that. You need to put the PA from here. PA equal to suppose 150 minus...
Sir, একবার ইকুয়েশন বসাই দিলে হবে না স্যার, ওটা মেগাওয়াটটাকে কি...
You just put the 150, that's it. Okay, PA equal to 150 minus PB.
Yes, sir.
So putting this equation here in this...
PA equals to 72.
72. Okay, and PB?
78.
Okay, can anyone cross check these values? Is it correct or not?
Yes, sir. 72 and 78.
Okay, fine. So our economical load sharing would be 72 megawatt and 78 megawatt for plan B. That is the values for PA and PB. Now the second part of the math, which exhibits that you need to find out the loss in fuel cost, okay, if load is equally shared. That means for two particular values, for PA and PB, let's say you need to reduce it and to a certain middle point, okay. Suppose your middle point is 75, you need to increase 3 megawatt to reach to the 75, and you need to decrease 3 megawatt to reach to the 75. So then you can say our load is equal, or such like that. For B, PA should be 75 and PB should be 75. In our real case, PA is 72. So you need to reduce or you need to increase 3 megawatt at least. And for PB, you need to reduce 3 megawatt. Then you can say, okay, right now our load is shared equally. In that scenario, for PA, the cost will increase, okay? For PA, you need to reach from 72 to 75, so cost will increase. So you need to find that cost, what about the value. And for PB, you need to reduce the cost. From 78 megawatt, you need to reduce it up to 75 megawatt. So cost will decrease. Okay, so here cost will decrease. So how to calculate that value? We can calculate it by a very simple equation, like for unit A, increase in cost equal to, it should 72 75, okay, 3 megawatt you need to increase. The equation is 0.06 PA for the first equation, 11.4, 11.4, okay. So you need to integrate the equation considering to the dPA, and then you will get for this equation, if you solve it, maybe the value should be like that, from 72 to 75, and for particularly respect to the P, you need to differentiate or integrate the equation. That means whatever the value in that scenario. For first,
Sir, answer is 47.43. Sir, একবারে লিখে দিলে হবে না answer?
Yes, you can write it down as well. Whatever the value?
47.43.
47.43. Okay, we can call it per hour, okay? BDT per hour, suppose. So if you solve this equation, the equation should like that. Suppose in respect to the dPA, you need to integrate this value, then the value should be half of the constant, and the PA should be square, and plus 11.4, that is PA should multiply. So that is the equation, 72 75. If you put the value here, then you will also get same value. Just cross check it that it is the same. And for unit B, decrease suppose in our scenario we are calculating the increment, right, as it is integration. So for decrement, you need to calculate it like the same thing, but the limit should be different. Suppose it should be 78 to 75, so it reduces, so it will provide you negative value. So PB plus 10 D of PB. So in respect to the dPB, you can calculate it. So the value should be like 0.035, half of that value, and PB square plus 10 of PB, as it is constant. So 80 to, sorry, 78 to 75. So can you calculate it again?
So minus 46.
Minus 46. 46.06. Yeah.
0.65.
0.65 per hour. Okay, see, previously it was 47 something dollar or BDT per hour, and it is minus 46 0.065 BDT per hour. So in that case, we can find the differences, right? The differences should be the net increment of that fuel cost. So if you just write it here, so net increase in cost due to we can say due to equal load sharing. Equal load sharing, or we can say not following the economic load distribution. So value should be 47.43 minus 46.065. Whatever the value, maybe
1.36.
1.36. Okay, fine. 36, right? Per hour. BDT 1.36 per hour. That is our net increase. So you see, if you have the not equal distribution, which is called economic load distribution for the first scenario, the pricing should follow the equation A and equation B, and they should be the similar. They should have similar tariff or similar fuel rate. Simple. So they have the similar cost. So suppose if it is 45 BDT per hour, for plan B it should be 45 BDT per hour, and because we are considering that for plan 10, plan B, maybe they have some different efficiencies. So we are putting, or we are keeping, or trying to keep the fuel cost similar for these two generators, and also we are trying to share the load like 72 and 78 to provide the maximum demand 150. But in second case, we shared the similar load with generator 1 and generator 2, but generator 1 may have different efficiencies, and generator 2 may have different efficiencies. They consume different fuel, so that their fuel rate is different. In that scenario, you calculate the cost and you find out that if they share the similar 75 megawatt load, their cost may differ. So for the first one, it should increase, suppose from 46 or 45 to 47 BDT per hour, and for unit B it is decreasing, maybe from 46 or 47 to 46 BDT per hour. So that represents there should have some fuel cost differences occur. For generator A, it is higher than the generator B, and the difference is almost 1 BDT per hour. So if you consider it's for a bulk economic production for a particular year, then you need to pay more, right? Rather than from the first scenario, you need to pay more in the second scenario. That is the main thing. Okay. Previously it was similar. So anyway, this is very important math. There is one math in the assignment as well. You need to solve it. Okay.
স্যার 75 ভ্যালুটা কি অ্যাজিউম করে নিব, মানে 76 ও তো ধরা যেত না?
No. In this scenario, we are considering the load distribution should be equal. Equal means 150. You need to divide it. That's it. If it is, if the total value is 200 megawatt, it should be 100, right?
Yes,
Like
sir.
that. Okay. So any question from anyone? Any question? Okay. So we will now start another topic. Just let me give 2 minutes to set up my slide here. So now we will cover another particular problem which is related to the station performance. So our next lecture would be related to station performance. But before going to the station performance theory, we will try to cover one problem which is called generator capacity or power plant capacity scheduling. Okay. So very important thing, we need to understand the issues. What is capacity scheduling? Suppose you have 4 or 5 generator plants in one diesel based power plant. Okay, diesel generator based power plant, 5, 6, 7, whatever, so many generator units there. You cannot run all the units at a time. You don't need to run that because according to your demand from the provider, service provider, or the PGCP, whatever, they will provide you the demand for this day, particular day, for hour by hour, whatever. So in that scenario, you need to start your generator 1, 2, 3, like that. So you cannot start the generator sequentially. You don't need to do that. Rather, you can start the generators considering their efficiency. Okay, you can make, or you can make a chart of those generator efficiency, and based on the order of efficiency, you can run the generators. Okay, turn on those generators. Number one. Number two is suppose you have a particular maximum demand. So before starting the next generator unit, suppose generator 1 is turned on based on the demand. So now demand is increasing, you need to turn on the second one. So all the time you should carefully keep some generating capacity above than your actual demand. Okay, so that you can face the unwanted scenario. So the unwanted rise of your demand, or due to the different events or different situations, so you can your generator would not be, or will not be in very overloaded scenario. So that's why some capacity should be above than the actual demand. So that is called maximum protected demand. Okay, so capacity scheduling considers that, it considers maximum protected demand. Okay, so what should be the capacity scheduling if you have some situation, or if you have some unit of generators? How to design that scheduling? Suppose there is a question like you have some or several power plant units. They have some particular capacity in megawatt, and they have some order of efficiency. So you can schedule your plant. So suppose these are the unit number 1, 2, 3, 4, 5, 6, 7. You have 7 units. So for unit 1, the unit 1 capacity is 5 megawatt, and it has the order of efficiency 7th. This is the last generator you need to turn on. The second unit maybe that should have 10 megawatt capacity, and maybe the order of efficiency 5. Suppose you have another 10 megawatt capacity generator, and that order of efficiency 6. Maybe you have another 20 megawatt generator. It has the efficiency order is 4. The fifth generator has 50 megawatt capacity. It has order of efficiency 2. Sixth generator, it has 50 megawatt capacity, order of efficiency 1. And last one has 70 megawatt capacity, the order of efficiency 3. So now you see there are several generator units. One has the maximum value and other has the sequentially lower values, but the order of efficiency is random. Suppose your sixth generation, which has 50 megawatt capacity, it provides you the highest efficiency, and the next one should provide it also provides you the 50 megawatt highest efficiency. So you can make the order of efficiency first and second. The third one is 70 megawatt, like that. The last 5 megawatt capacity unit has the order of efficiency very low efficient generator. In that scenario, in that conditions, how can you schedule the capacity for your area, for your load? Okay, that is the main thing. So the considerations are: first, the most efficient machine should be placed in service in the first positions, and according to that, from the descending order, we can run other machine or other generators at the last place, which has lowest order of efficiency. And load is actually divided in a incremental rate. Suppose load demand is increasing, you need to add more generators. Okay, but you must keep in mind that suppose if the generator plant capacity, suppose 200 megawatt, it doesn't mean you need to provide the load maximum demand should be 200 megawatt. You should keep some protected demand. That is called maximum protected demand. We run the power plant up to 150 megawatt. The 50 megawatt would be, or maybe I'm considering that 50 megawatt is my protected demand. Okay, so that should be the upper range for me. So in that case, how to schedule this situation? So let's start the scheduling. So first we need to prepare a chart. So for that, we are considering the system load. Here we can write down the megawatt values for that load. Here we can put the unit when we need to turn on the units. Suppose these are the number of units: 1, 2, 3, 4, 5, 6, 7. And the total you can cover, total demand, total megawatt you can cover. You can write it in the right side. So for that, we can draw some lines to make it very clear. Okay. For the first scenario, you can consider that our very first, in the first scenario, we don't need to provide any load. Suppose 0 megawatt, or from 0 to upper 0 plus. Okay, for 0 or 5 or 10 or 20, that type of megawatt, 0 plus, above 0 or 0 above, you need to run some of the power plants. The first power plants you need to run, which is first one is 50 megawatt, you can run, and another is you need to run some power plants. Suppose 0 to first one is 50 megawatt. So you can run the first one, which is the number 6, the first one, efficiency first. So we can turn on this first power plant, 50 megawatt. But the thing is, if you just consider your system load or load demand is increasing from 0 plus, maybe 10, 20, 30, all the demand is protected by this 50 megawatt. But what if it reaches up to 50? When it reaches up to 50, you need to turn on the second generator, but you cannot immediately turn on the generator. As load is dynamic, load will frequently increasing, or it will increase very within a very small amount of time. So keep in mind, if you turn on first generator, considering that up to 50 megawatt, the load will increase very swiftly. So at that time, you should have another power plant in running condition, so that you don't need to worry about frequently turning on the another generator. Suppose your load demand is 40 megawatt, you don't have that amount of load to protect the extensive demand. You need to turn on the second, but the second one will take time. So that you need to parallelly turn on second generator in the first scenario, so that you can very you can turn on the generator beforehand to keep the overall load sharing secured. Okay, so this is for 0 plus load, 0 to 50 megawatt. So up to 50, you are providing 100 megawatt load with these two generator. This is the first scheduling. Okay, next one, 0 to 50 megawatt. Suppose it reaches to 50 megawatt. What will happen then? If it reaches to 50 megawatt, that means your range should be 50 plus 50. That means you don't need to worry up to 50 megawatt, because one generator is providing 50 megawatt. So you don't need to worry about the 50. But what if it reaches to 50 plus, 60, 70, 80, 50 plus? Okay, what will happen then? 50 plus is a worrying thing for you. You need to turn on another. You need to start the process for another generator, because it will rise very within a very short time up to 100 megawatt. So that you need another plant. So what should be the another plant? The third one. Third one is, you see, it is 70 megawatt. The third one. So we are turning on the third generator. First one, second one done. Third one is 70. So turn on the third one. So in second case, it is 100, but in third case, 50, 50, and the third one is 70. You turn it on. So what about the total load demand? You can provide the 170 megawatt load, but your load demand is 50 plus, maybe 60, 70, 80, 90, like that. And after that, this load demand is increasing, and some point it will reach to 100 megawatt. So if it is 100 megawatt, your plant 150, plant 250, it will provide you that 100 megawatt, no worry. So the 70 megawatt is your extra. So no problem. Your third plant is running, so no issues up to 100 megawatt. But after 100 megawatt, then there will be some issue, because you need to turn on or start the process of turning on the other generators. So that is the worrying thing. So we need to prepare, and we need to start the fourth generator if the load demand is 100 plus. For 100 plus, you see, you have the fourth generator, which has the fourth efficiency order, 20 megawatt. You can turn it on. So 1, 2, 3, 4. This is our fourth part. We can turn on the 20. Previously 50, 50, 100 is there, 70 is there. As you are your demand is rising, you make it 20. So overall you can protect 190 megawatt. Here you can observe that the question should be arise that, sir, for 100 plus megawatt we have the 70 here, so up to 170 we can provide the backup with this 70, so why do we need to arrange another 20? The question is here, previously we have observed when the range of one generator reaches, we start the another one. So here up to this level we protect by using two generators. One is for 50, but here we have reached 50-50. That means above that we can we have to start another generator. That is the main concept. So we start the another 20. But you can ask me that, sir, up to 170 should not it be protected? Yes, that should be protected, but our consideration is we should have some maximum protected demand. Considering to the maximum generator megawatt is 70, we take it as maximum protected demand from here, so that our load demand right now increasing based on the lower end efficiency generator. Rather, we can protect if suppose generator 20 somehow broke down, so we can somehow meet up that particular 20 megawatt demand by using this very high megawatt generator unit. That's why that unit should be our protected demand. We don't cross that demand. Suppose if your maximum demand is 200, we don't cross it up to suppose 150. So that 50 should be in our hand. That generator plan is running. It is in our hand. If there is any issues in other generator plan, then that 50 or 60 or 70 megawatt, the big unit will support you. That is the main idea. So now from this point, we will consider our load demand based on the smaller generating unit. So for 100 plus, the overall value should be 190. And if you consider above that 100 plus, what should be the load demand value? It should be based on the smaller value. So next value should be, it reaches up to 120. So if it is 120, don't need to turn on any generator because you have maximum protected demand 70. It reaches 120, 50, 50, 20. It will cover the whole demand. So you don't need to worry about it. The value is similar. But if you consider more than 120, 130, 135, suppose 130, what about the value should be? You see, if it reaches 130, you have another 10 megawatt generating unit, the fifth efficient 10 megawatt unit. You can run it on, right? So you can turn it on, second one. So it should be 10. You have 20. You have 50, you have 50, you have 70. 70 is our protected demand. So 20, 50, 50, 10. All those covers 120 plus. Right? So that should be 200. And if it reaches to 130, because 20, 50, 50 is 120 and 10, 130. Then you don't need to worry. If you have 130, you can cover it by using the similar units. So that is our 200, no worries. But on top of that, if you increase the load demand 130 plus, what will happen? So if you have 130 plus, you need to turn on another unit. That means 140. So the next plant is 10 megawatt, the sixth generator. Turn on the sixth, second and third generator. So you need another 10 megawatt. So previously 10, next 10, 20, 50, 50, 70. So the value should be 210 overall. So you see, generator 2, 3, 4, 5, 6, 7, all the generators are turning on, but we are counting only this part. 120, 30, 40, 140. If it is 130 plus, you need to turn on the next generator. That's why we have turned it on, and you can cover 210 megawatt up to this. And what will happen if you consider 130 plus mean another the next value? The next value should be, you see here, 50, 50, 20, 110, 120, 130, 140, total 140. We can write it down 140 after summing or adding up those values. This is the next value. So if it is 140, you can cover it very easily by using these generators. So it should be similar as 130 plus. What will happen the next? And next value should be 140 plus. 140 plus. Why? What about the 140 plus value? For 140 plus, you have last generator, 5 megawatt generator, the last efficient generator, 5 megawatt only. So you can turn that 5 megawatt plant. 5, 10, 10, 20, 50, 50, 70. What about the final value? 2, 15 megawatt. Here you can observe that 140 plus can reach up to 140 plus 5, 145 megawatt. That is our maximum demand that we can support. Okay, we can reach up to. That means the plant operation engineers can schedule 145 megawatt can be supplied from this power plant. So what about the other unit? That 70, you see, you have the value up to 215, and you have supplied 145 maximum. So what is the value? What is the difference between 240, 215 and 145?
70.
Yeah, 215, 145. That means 70 megawatt unit. That 70 megawatt unit is our somehow
Loss.
we are considering that megawatt is for protection purpose. Suppose maybe considering that 5 megawatt unit somehow or 10 megawatt unit somehow you lost that unit during on a particular day in an operating condition. Somehow they failed. We considering the probability of outage, right? So maybe for different issues, these two plant just shut down in a particular day. So that 70 megawatt unit will help you now. The third generating unit, the maximum efficiency unit, it will provide that 20 megawatt instantly. You don't need to worry, right? Suppose this 20 will shut down. Total 40 megawatt it can provide. Suppose this 5 unit shut down. Whatever the value, 45 megawatt it can support. Suppose all the units are on, but 50 megawatt somehow 150 megawatt just in a outage condition, the extreme scenario, it can support. That is the that is for protection purpose. So maximum demand we can protect by this scheduling is 145 megawatt, and the power plant, third unit of that power plant, which is 70 megawatt, can help to schedule in an bad scenario, in a very uneven scenario, okay, during a very harsh scenario. So that is the main objective of capacity scheduling. So we are not supporting or we are not providing the 215 megawatt into the system or into the load. Rather, we kept 145 megawatt hour protected demand. We protect the demand by using 6 generators, and 1 generator is protecting my whole plant. Okay, so that is the main objective of capacity scheduling. So keep in mind that the value you are taking for protection demand, from that point your load demand is changing. Here 100 plus, you can ask me, sir, the next value should be 170. No, we are considering the next generator to sum the load, as we consider 70 is our maximum protection demand. Okay, so this is 100, then the next value 120, then the next value 120 plus, next next value is 10, we have the plant 10 megawatt, so it should be 30, then we have another 10 megawatt, that should be 140, and we have last 145 because we have only 5 megawatt generators. That's how we sum up the left side values and we sum up the right side values considering how many plants are turned on, the total or maximum load we can supply. But we are not supplying to 15 megawatt, rather we are supplying 145 megawatt. So that is called our capacity scheduling. It's very important math. It will be on the exam. Okay, maybe the values will be different. You need to schedule the thing based on your knowledge. Okay. Any question?
No, sir.
Okay.
স্যার আপনি বললেন স্যার ভ্যালু স্যার ডিফারেন্ট হবে স্যার, আপনি যদি ম্যাথ দেন তাহলে ওখানে কি স্যার আমাদের ম্যাক্সিমাম যে ক্যাপাসিটি আর কি মানে ধরে রাখার এক্সট্রা ওটা কি স্যার সেম 70 থাকবে না স্যার, ওটা চেঞ্জ হতে পারে?
It will be mentioned, or you can take it, or you can assume it. Okay, you need to design or you need to schedule the whole plan based on your idea, based on the data. So it can differ from person to person. Okay? But the idea is if there is any plant or if there is any generators in higher efficiency order which has the maximum megawatt which has, okay, you can take it as your protected demand.
Oh, so the maximum one will always be the protected demand,
But
sir.
in the higher efficiency order, not in the lower. Suppose in third or fourth position you find, yeah, I have one generator which has the efficiency in fourth or third order, maybe the efficiency value is higher than other generating plants, so we can take it as our protected demand. That is the idea. Okay,
Thank you, sir.
good. So I think we have last one class left in the next Sunday. So should we continue today's class, or we have just one topic left? We can cover it in the last class. So if you want, we can stop it here and then cover it in the next class. That would be our last topic.
So next class will answer.
Next class. Okay, fine. So do you want to sit for quiz? Any quiz? Very small type of quiz in the last class?
Sir, today, sir?
No. In the next class, we can take one quiz, very small quiz, based on today's lecture. And one math will be there for 20 minutes. And then we can continue the class for another 30 minutes, and then it will be the last class. So if you want, okay, I will not take the class on Tuesday. Okay, Tuesday means 12th, so I'll not take any class on 12th. So in Sunday it will be our last class. So I want to take one quiz so that we can have we can just take the best one from two quizzes. Okay, so is it possible to sit for quiz on Sunday during class time via online and based on today's lecture?
Okay, sir.
Yes, sir.
Okay, sir.
Any confusions? Anyone?
No, sir.
Fine. I am taking it positively, so I'll post it in the classroom. In the next Sunday will be our last class, and there will be one class test based on today's lecture. Okay, I'll post it in the classroom.
Okay,
The
sir.
two maths here, you need to practice these two maths. I'll change the values. That's it. The similar math.
স্যার একটা কুইজ কাউন্ট করবেন দুইটার মধ্যে?
Yes, I will count one quiz.
ওকে স্যার।
Okay. So thank you so very much. I'll take the attendance now.
স্যার আমাদের ফাইনাল এক্সাম কবে হবে স্যার?
I think you know the
This Friday.
schedule. Yeah, on 20 by online.
ওকে স্যার।
So Tahmidur Rahman Tahmid,
Sir.
Fahim Abrar,
Yes, sir.
Utsho,
Present, sir.